Data structures define different ways of storing data in memory, and how you store your data matters. When using the wrong data structure, this can make your code significantly slower. On smaller projects, maybe this doesn't matter too much, but on larger projects, slower code means higher computation costs, and higher computation costs can potentially be in the millions. The first data structure we're going to look at is an array. An array is just a sequence of elements. So in this example, we create a variable topics, and the type is going to be string array. Using the brackets will denote any type to be an array of that type. To create the array, we once again use the brackets, and then you can populate it with values. So the array that this code would create is this array here. The first element would be TypeScript, the second element HTTP, the third element Express, and the last element SQL. Now arrays are always indexed from 0. So in this array, element at index 0 is TypeScript, at index 1 is HTTP, at index 2 is Express, and index 3 is SQL. To access an element by index, you'd use array, bracket, and then the index number that you want to access. So in example here, it'd be console.log topics at index 1. Index 1 would be HTTP, so this code will print HTTP to the console. The next line of code, where we say topics at index 2 equals KOA, will replace the index 2 express with the value KOA. So index 2 is replaced with KOA. There are several other properties of arrays that we want to look at. The first property is .length. The .length property will say how many elements are in the array. So if we say console.log topics.length, this will print 4 to the console as we have 4 elements in our array. The next property we want to look at is a function called push to add new elements to an array. A function assigned to an object is also known as a method. So the push method, we will say topics.push and we'll provide it a new value. And when we do this, a new value will be added to the end of our array. The next method we want to look at is the pop method. The pop method will remove an element from the end of this array. So in this case, we say topics.pop, and the last element is SQL. So when we run this method, it would remove that last element. If we instead want to remove the first element in the array, we would use the shift method. The shift method will remove the element at the start of the array, and afterwards, the indexes would be shift, so now HTTP is at index 0 as it is the first element of the array. If we want to add an element to the start of the array, we would use the unshift method. The unshift method will add to the start of the array, and in this case, we would see the indexes would be reordered again, such that that first element is the new index 0. But what if we want to remove elements or add elements to the center of the array? To do that, we can use the splice method. For the splice method, we specify a start index, how many elements we want to delete from that index, and new items that we want to add at that index. So in this example, we'll say splice starting at element 1, remove one element, which means we would just remove HTTP, and add the elements React and HTML in its place. So when we do this, HTTP gets removed, React and HTML get added. There are more methods on arrays, but that's all we're going to talk about for now. The key takeaways from arrays is going to be that they maintain order, as that's the purpose of their indexes. They allow duplicate entries. We didn't look at this, but if we wanted to add HTTP in a second time here, there'd be no issue doing so. When accessing elements by index, it's extremely fast. So when we say array bracket 1 to get HTTP, that operation is incredibly fast. However, they're often used very inefficiently. For example, if we didn't know if HTTP existed in this array or not, we would have to iterate through the entire array in order to find out if something exists. In this scenario, a much better data structure to use would be a set. A set is an unordered collection of data which does not allow for duplicate values. When specifying the type for a set, you would say the type is set, and then inside of the angled brackets, you would say that the type of data stored in the set. So in this case, we want a set of strings, so we say set, angle bracket, string, closing angle bracket. And in this set, we're going to add the same values, TypeScript, HTTP, Express, and SQL. However, to visualize this set, there's not really any sort of guarantee of order. They just exist within the set. Now, sets have several methods that we also want to look at. What a set is very good at is determining if it already contains an element or not. So to do that, we'd use the has method. So in the first case, we would say topics.has the string HTTP. And since the set does have HTTP, this would return true. And the next line, topic.has the string React, would return false since the set does not contain the word React. If we want to add new elements into the set, we would simply use the add method. We'd say topics.add, and in this case, we can add the topic React. If we want to remove elements from our set, we would use the delete method. In this example, if we were to say topics.delete Angular, it would do nothing since Angular is not already contained within the set. However, if we say topics.delete Express, Express would be removed from the set. That's all the methods I want to look at for sets. So in review, sets have no order, they do not allow for duplicate entries, and checking if an element exists is very fast. Maps are simply a collection of key-value pairs. In a map, all keys must be unique. To define the type for a map, you'd use the map keyword, and then inside the angle brackets, you first give the type of the keys. So in this case, we have keys of type string, and then you give the type for values. So we have values of type number. In this map, we're going to be creating topic ratings. So the first entry we want to add is going to be a key TypeScript with a value 10. The next entry we want to add is going to be Java with a value of 1. Or actually, we'll replace that and we'll say Java with a value of 2. Then we have SQL with a value of 6 and AWS with a value of 8. So to add entries to the map, you would use the set method and you'd provide it a key value pair. To remove an entry from a map, you'd use the delete method and all you need to provide is the key. So in this case, we'll say topic ratings.delete Java, and now our map no longer has that entry. If you simply just want to see if a key exists, you can use map.has. So in this case, we'll say topicsrating.has TypeScript would return true since TypeScript is a key in our map. If we were instead to say .has PHP, this would return false as PHP does not exist in the map. And lastly, if we actually want to get a value associated with a key, we would use the get method. So in this example, we would say topicratings.get SQL, which will return 6, as that's the value associated with the key SQL. The key takeaway for maps is that they are a collection of key value pairs. They do not allow for duplicate keys, and accessing values by keys is extremely fast. In my opinion, maps are the most OP data structure, and a lot of problems can be solved most efficiently when using maps.